This is chapter 5, Discrete Probability Distributions. Today we are going to discuss about section 5.2, Binomial Probability Distributions, including parameters. First of all, we have a key concept about binomial probability distribution. It allows us to deal with circumstances in which the outcomes belongs to two relevant categories, such as acceptable, defective, or survived, died. That means in binomial probability distributions, we have two possible outcomes, only two categories, like failure, success, or survive, died. Likewise, we have only two relevant categories of each and every outcome. Then we can use binomial probability distribution. Then normally if it's a binomial probability distribution, it meets these following four requirements. Okay, the first thing is there should be a fixed number of trials. Fixed number of trials means sample size. Sample size is n, so the sample size should be fixed. Also, those trials should be independent. Also, for each and every trial has only two possible outcomes, or not more than two, only two. That's why it's binomial. So each trial definitely has only two possible outcomes, that means success or failure. Then the last requirement is in each and every trial should has the same constant probability of success. That means there are two possible outcomes, then each and every outcome we have two parts, success and failure, and the success probability should be same or constant in each and every trial. Then we can say this is a binomial probability distribution. For that, it meets these four requirements. Then we have some notations. You have to know about these things when you want to learn about binomial probability distribution. First one is simple n. Simple n is sample size. That means according to this section, the fixed number of trials. Simple x is a specific number of successes in n trials. So if we have n trials, we can have zero number of successes, one success, or up to n number of successes. That means including 0 and n. Then a simple p is the probability of success in each one trial. Then q is the probability of failure in any one trial. The p is success probability in each trial. Q is the failure probability in each trial. If you want to find Q, you can use P. So please remember, this is very important formula. If you want to find the failure probability, you can do is 1 minus success probability. Then what is this? Probability of getting exactly X number of successes among the n trials. Okay, so this is the thing we want to find using this binomial distribution formula. So the probability of getting exactly X successes among n trials, that is the thing we are going to find. Then you have to make sure that X, this one, and P refer to the same category being called a success. So X is about successes and P is also about the success probability. Then we have an example. The proportion of adults over 25 with a bachelor's degree is 0.25. Suppose we want to find the probability that exactly 2 of 4 randomly selected adults over 25 has a bachelor degree. Now you want to check whether this procedure results in a binomial distribution. For that, we want to check those 4 requirements. The first one is this should have fixed number of trials. Yes, it says it has four randomly selected adults, so the n is fixed. Also, those four trials should be independent, yes, because we have four adults. Then each and every trial it has only two possible outcomes. It's also correct. The one possible outcome is adults over 25 with a bachelor degree, that is a success. Then the failure is adults below 25 with a bachelor's degree, that is the failure according to this example. So it has two outcomes. Then the last one is each trial has the same constant probability, success probability. Yes, it's correct, because here this is the success, adults over 25 with a bachelor degree. So the probability of adults over 25 with a bachelor's degree is 0.27. It is constant. It is same for each and every trial. It is same for all four adults. So this example meets those four requirements. So we can say this procedure result in a binomial distribution. Then we have to know about this special notation. What is this? Factorial symbol. So it is this, okay? Exclamation mark. It is factorial symbol. What is the meaning of this symbol? It denotes the product of decreasing positive whole numbers. Okay, so for an example, if you want to find factorial 4, the meaning of factorial 4 is the product of decreasing positive whole numbers. So 4 times, 3 times, 2 times 1. You have to decrease your positive whole numbers up to 1, because that is the least positive whole number. It is 1. So factorial 4 means 4 times, 3 times, 2 times 1. So it's 24. Likewise, if you want to find factorial 3, then it is 3 times, 2 times 1. Right, if you have any factorial number, start from that value and decreasing up to minimum positive whole number. Then in there you have to multiply those all numbers, then you can find the value. Then there is a special definition, the factorial 0. Actually there is no meaning, that's why we have a definition. Definition means we have to accept, okay, we cannot argue. So it's a definition. 0 factorial is 1. Very special thing, please remember. 1 factorial is 1, it's correct, but 0 factorial is also 1. You have to remember this, okay. Then this is binomial probability formula. This is the one. So if you know how to use this one, we can find these probability values. Okay, this is the formula to find the probability of exactly x successes out of n trials. Okay, we can use this formula. Here, what is n? It is number of trials. Okay, total number of trials. Then x is what? The number of successes. Okay, then simple p is the probability of success in each trial. Q is the probability of failure in each trial. Okay, now you know what is n, x, p, q. Here it's again x, number of successes. So if you know everything, then you can find this part, probability of getting exactly x number of successes. Okay, then what is this part? This is not a special thing, because you know what is this. This is factorial mark. So this is factorial number. Here again factorial number, factorial number. So if you take this as one part, one whole part, we can represent this as this way also. What is this? N choose x. This is about it is about combinations. Okay, so n choose x. How can we represent this way? So if If you see this or instead of this, if you see this, you have to know both are same. N choose x means this one, okay? Now, what is the logic behind this binomial formula? This is the previous formula, same thing, okay, this formula. What is the logic behind this formula? From this first uh, part, this factorial part, we can find number of outcomes with exactly x successes out of n trials, okay? So we can find number of outcomes with exactly x successes out of n trials. Then using last two parts, px times q n minus x, we can find the probability of x successes out of n trials for any one particular order, okay? So that is the second part. So this is the rationale or logic behind the formula, but you don't need to think about too much. If you know the formula, just apply values, then you can find the probability value. But this is the meaning behind this formula. Now we have an example, multiple choice. I will show you how to use the binomial distribution formula. First, read the question. A student randomly guesses at a three question multiple choice question. So in the first we can see we have three question multiple choice quiz. So we have a quiz. It has three questions. That means n should be 3. Okay. Then each and every question has four choices. Okay. So out of four answers, we have only one correct answer. Normally correct answer is our success. Why? According to the question, because it says what is the probability that the student gets exactly two questions right. So here it's about right questions. That's why here the success probability is what? Each question has four choices with only one correct answer. So 1 over 4, 1/4 is our success probability for each trial. Got it? Because each and every question we have four possible choices. Out of four, we have only one correct answer. So what is the success probability? 1 over 4. It is the success. Why? Because the question is also about right questions. Okay. Then now we know the probability of success. We know what is our n, it's 3. Then if you know p, probability of success in each trial, we can find q. Q is the probability of failure in each trial. How can we find q? It's 1 minus p. Okay, q is 1 minus p. Then the last one, what is the probability that the student gets exactly two questions? So that is the question we want to find. Exactly two questions right out of three. Out of three means our sample size n is 3. We need exactly two questions. That means x is 2. Yes, here can you see x is 2. But here first check requirements. You know how to check requirements. We have four requirements. This question is under the binomial distribution formula. So definitely it follows binomial distribution. Otherwise we cannot use this formula. So check. It should satisfy those four requirements. After that you have to identify npqx. So we know what is it's 3, p it's 1/4, q is 0.75 and x is 2. Now finally you can calculate the probability of exactly two questions right out of three. So we can find this. Now I will show you how to do this using the binomial distribution formula. Okay, here first you have to identify what is n. It's 3. Then what is p? Success probability in each trial, 1/4. Then how can you find q? 1 minus P. 1 minus P. Then it should be 1 minus 1/4, 3, 3/4. Then the last one is X. What is X? Exactly two questions right. So X is 2. So we have everything NPQX. Now use the binomial probability formula. This is the question. Yes, X is 2. Yeah, that's why here we also got the same thing. X is 2. Now what is the formula? N factorial n minus x factorial px q n minus x. This is the formula. Okay. Okay. Then what is n? It's 3. What is n? Again it's 3 minus what is x? 2 factorial. What is x? 2 factorial. What is p? 1/4. X is 2. Q is 3/4. N is through 3 minus x is 2. Okay, so this is the way of substituting values for the formula. Okay, so this is the one. Now you can calculate this value using your calculator, but I will show you how to do this. Okay, here it's factorial 3. 3 minus 2 is 1 factorial, then 2 factorial, rest will be same. Here it's 1. 3 minus 2 is 1 means here it's 1. So you don't need to write 1. Okay. Now I will tell you some special thing. Okay. How to find the value of this part. Okay. How to simplify. I will tell you. Here 3 factorial divided by 1 factorial, 2 factorial is what? You know, do you know how to write 3 factorial? If you want, you can write this as 3 times 2 factorial. Is that correct? Yes. Why? 3 factorial means 3 times 2 times 1. So we can write 3 times. Then 2 times 1 is 2 factorial. So if you have this, you can write this as 3 times rest 2 factorial. Then 1 factorial is 1. Okay, so you don't need to write that part. 2 factorial, write it as that way, 2 factorial. Why I write up to 2 factorial? Because in this denominator we have 2 factorial. Then you can cut like this, cut. Got it? Now what is the answer? 3. So the answer for this factorial part is 3. It's very easy. Okay, so always write, simplify, then you can cut. Then 3 times and 1/4 is 0.25 squared 0.75. So the answer is 0.047 0.141. So the answer is this. It's multiplication mark. Okay, so 3 times 0.047, the answer is 0.141. Okay, so this is the answer for slide number 30. Okay, now we have a next slide. This is the logic behind previous example. Okay, I will explain. It says we have 3 questions and we have to pick 2 correct questions. Okay, but we know if you pick one question, there are 2 possible outcomes. So what are the total possible sample space? 2 to the power 3. That's why we have 2 to the power 3 means 8 possible outcomes. Remember in previous chapters we learn about this, like if we toss three coins, what are the possible outcomes? Then using tree diagram, you can draw the possible uh, value possibilities in our sample space. Likewise here, if we have three, what are the possible outcomes that we can have? It's something like this. Correct means C, wrong means W. Okay, so all questions can be correct, or first two can be correct, then last one can be wrong. Likewise here all questions are wrong, not correct. Likewise there are 8 possible ways. Then we have 8 possible ways. Out of 8, we have 3 outcomes with exactly, here it's wrong, it should be 2. Okay, 3 outcomes with exactly 2 successes means correct, 2 successes. Px is equals to 2 is what? This one or this or this. We have 3 ways. Okay, so then each we have 3 values, then each outcome, that means each of these values, this one or this, uh, each outcome with 2 successes has the same probability of this. Is that correct? Yes. Why? Because what is the probability of getting success in each trial? 1/4. That means 0.25. Then multiply by 0.25. Multiply by 0.75. If you multiply 0.25 times 0.25 times 0.75, you will get this value. Okay, 0.047. Then we have 3 chances, so you have to multiply this value by 3. Then you will get the final answer. It's 0.141. In the previous slide we discussed, we got that value 0.141. That means 3 times this value. Okay, so this is the logic behind the previous example. So if you want, you can use the formula. Oh, this is the logic, but this is really difficult. So yeah, so don't need to think too much. I will not ask about the logic behind the examples. Okay, so the only thing, you have to use the binomial distribution formula, then try to recognize what is your n, x, p, q, then substitute those values in that formula, then you will get your final probability value. Okay, then next slide. Next example, bachelor's degree. Actually we discussed this example, but we didn't find the value, but we check the requirements. Okay, so what is this? So you know what is this. Given that there is 0.27 probability that any given adult over 25 has a bachelor's degree, use the formula, binomial distribution probability formula, to find the probability that exactly 2 adults over 25 with a bachelor's degree when 4 adults over 25 are selected. Now you have to identify these values. What is n? Here it says we have to uh, pick exactly 4 adults over 25 with the bachelor's degree when 4 adults are selected. So n is 4. What is P? Probability of success. Probability of success in each trial. It is this 0.27 is the probability that any given adult over 25 has a bachelor degree. So that is our probability of success, 0.27. Q means 1 minus this value, 0.27. X is, here it says exactly 2, so X is 2. Yes, you want to find what? Probability of X is equals to 2. So yeah, X should be 2. Yes. Okay, now we have everything. Now I will show you how to do this example. Okay, uh, this is slide number 32, bachelor's degree. The first thing you have to identify what is your N. It is 4. Then what is P? It's 0.27. Then what is Q? It's 1 minus P. So 1 minus 0.27. So 0.141. 7, 3. Then last one, what is x? Exactly 2. So that is 2. So the next thing, we have to find probability of x is equals to 2. So first thing, write the binomial probability formula. Okay, now you know what are the values. What is n? 4 factorial. 4 minus 2 factorial. X is 2. P is 0.27. X is 2. Q is 0.73. X is n minus x means 4 minus 2. Okay. Okay, now I will do this part separately. Okay. Then it will be easy to understand. 4 factorial divided by 4 minus 2 is 2 factorial, again 2 factorial. Now I told you here we have 2 factorial, so if you can write this like with 2 factorial symbol, then we can cut. How can we do that? We know 4 factorial means 4 times 3 times 2 factorial. Okay, 2 factorial means 2 times 1, so 4 factorial is 4 times 3 times 2 times 1, but we can write 2 times 1 as 2 factorial. Then we can write 1 2 factorial as 2 factorial is 2 because it's 2 times 1. If you want, you can write. Then this 2 factorial you can cut. Then what is the answer? It's 6. So what is the answer for this part? It's 6 times 0.27 squared 0.73. 4 minus 2 is 2 squared. So what is the answer? 0.233. Very simple. Okay, if you know NXPQ and try to how to know how get the factorial part, the answer for the factorial part, it's very easy. Use the calculator and do rest. In here also, if you want, you can use calculator, but I think this is very simple. You can cut if you know the procedure how to do this, or if you want, you can directly use your calculator. Okay, anyhow you need to get this correct answer. So this is the answer for slide number 32, 0.233. Now we have another example, doctor visits. Okay, same thing we have to do, but with different values. Here, this is the example. Suppose about 45% of the population has type O blood. Then if 8 individuals are selected, so what is our N? It's 8 are selected at random from the population. What is the probability that exactly 6? So what is our X? It's 6 of them have O type O blood. But what is our P? Here it says suppose about 45% of the population has type O blood. So that is our P. Why? Because the question is also about the same thing. The probability that exactly 6 of them have type O blood. So what is the probability of having type O blood? 45% of the population has type O blood. So this is our P, 45%. I told you how to convert percentage into decimal or proportion. Okay, I will again show you that. Then if we know everything, we can find this probability value. Probability of x is equal to 6. Then we have another part. We'll see how to do that one. Okay. Okay, now I will show you how to do this example. Okay, this is the example, slide number 33. First thing you have to recognize what is our n. It's 8 because we have 8 individuals. Then this is the important thing, probability of success. It says it's 45%. Now I will show you how to convert this into percentage of, how to convert this into proportion or decimal. 45% means always divided by 100. So this is the proportion, or if you want, write this as this way, 0.45 as decimal. So I will write it this way, P is 0.45. Okay, if you know P, you can find Q. It's 1 minus P. So 1 minus P is 0.45. So what is our Q? It's 0.55. Okay, now what is our X? It says exactly 6. So X is 6. Okay, now we have everything. Now we can find probability of X is equals to 6. So first you have to write the binomial probability formula. Okay, so this is the formula. You have to know how to plug values in this formula. What is our n? It's 8 factorial. 8 minus 6 factorial. 6 factorial. P is 0.45. X is 6. Q is 0.55. Here 8 minus 6. Okay, now simplify. Okay, I will do this factorial part separately. Okay, here 8 factorial, here 8 minus 6 is 2 factorial, then 6 factorial, then here we can see 6 factorial. So I can write 8 factorial as this way. Okay, 8 times 7 times 6 factorial. Got it? Then we can cut that 6 to this 6. That's why I wrote like that. 2 factorial is just 2, then 6 factorial. Now you can cut these two. Okay, now what is the final answer? It's 28. It's very simple. Okay, okay, it's 28. Now I will write it here. Here it's 28 times 0.45 6 0.55 squared. Okay, now use calculator and multiplication. This 28 times 0.45 6 to the power times 0.55 squared. Then what is the answer? Using calculator we can find this answer. It will be like this. Okay, if it's a probability, right up to 3 decimal places. Okay, now this is the next part of that same example. What is the probability that at least 6 people have type O blood? Okay, now we have inequality, not exact value, not exact X value. So I will tell you how to do that one. Okay, here the question is, what is the probability that at least, so X should be at least 6, at least 6 people have type O blood. Now you want to find this one. The meaning of this is what? X, the what is the probability that at least 6? At least 6 means what? 6 or more. Okay, so it means 6 or more means at least 6. At least 6 means 6 or more. Okay, so that's why I wrote X should be greater than or equal to 6. Now we have inequality, but I told you if we have inequality, what we have to do? First you have to recognize what are the corresponding X values. Okay, okay, here you know how many individuals we have? N. So N is sorry, how many individuals we have? 8. Okay, 8. We know N is 8. Remember in the beginning we wrote n is 8. That means we have 8 individuals. In here, x is less than or equal uh, 6. Okay, uh, that means sorry, actually this is wrong. 6 or more means the other way. Okay, I will erase here this. Okay, this side. Why? 6 or more. X should be 6 or more. At least 6 means x greater than or equal 6. Okay, so this is the correct one. Then we know n is 8. That means we have 8 individuals. In the first 2 or 3 slides, I told you what are the possible x values that can have. If we have n, x can be 0 up to n, including 0 and n. That means we can have 8 also as our x, because we have 8 individuals. Okay, here it says x should be greater than or equals to 6. Okay, now tell me what are the possible x values we can have. 6, 7 up to 8. Why? Because we have 8 individuals. Okay, you can write further, only up to 8. X is greater than or equal 6 means 6, 7 and 8. Now we know what are the possible x values. Now we can write this, because we want to find this. We can write this as what? This way. Remember we did this like these examples in previous slides. Okay, in here if you have inequality, you have to do the same thing for each and every x values. Okay, now can you see, if you want to find this one, you have to find these 3 probabilities separately. But first one you already know, the probability of x is equal to 6. We know what is that value because we got that value here. Probability of x is equal to 6 here is 0.70. But now we have to find 2 more, this and this separately. Okay, now I will do that one. First you have to find x is equals to 7. How can we find? Use the formula again. P x q n minus x. What is n? 8 factorial. 8 minus, now x is 7. Okay, p is same, pq is same. X is 7. 8 minus 7. So what is this part? What is the value? 8 factorial, 1 factorial, 7 factorial. So you can write it as this. So the answer is 8. 8 times 7 to the power 0.55. Here it's 1. So what is the answer for this one? 0.0166. Okay, so if x is equal to 7, this is the probability. Now the last one, we need to find this probability also. Again, use the binomial probability formula. Write it down. It will be, then it will be easy to substitute values. 8 factorial, here n is 8, x also 8. X is 8. 0.45. 8, q is 0.55. 8 minus 8. Why? Because n is 8, x is 8. Both are 8. Now, how can you find this one? Here, can you see? You can cut. Now, the numerator is 1. Then here, 8 minus 8 is 0. I told you there is a definition. 0 factorial is 1. Okay. So, times 0.45 to the power 8. Now here, what is this? 8 minus 8 is 0. 0. What is the power? If you, no, sorry, what is the value if you have the 0 power? Okay, it is 1. Okay, you have to know these things. These are basic calculus. If you have any value to the 0 power, then definitely it's 1. So this part also 1 multiplied by 0.45 to the power 8. Again it's 1. So what is the final answer? Just this. Okay, the answer is 0.002. Okay, now we have all three values. Here we want to find this value. For that we need this probability, this probability, this. Now we have all three values. The first probability is 0.070. I will write here. Okay, 0.070. What is the next one? Probability of x is equals to 7. What is the value? This one, 0.016. 0.016. What is the last probability value? X is equals to 8. The value is this. Okay, so 0.002. So what is the answer? Add them all, 0.088. So this is the final answer. Okay, 0.088. Okay, so now you know, if you have one x value, exact value, you can find it using binomial probability formula. Then if you have inequality, the first thing you have to find what are the corresponding x values. Then according to that, separate, divide this whole inequality to equal parts. Then separately find these probability values using binomial probability formula. After that, add those all probability values. Then you can find like this. You can find the final answer. Okay, this is all about slide number 33. Okay, now next slide is about new part. Okay, here we are going to use this table A1 in appendix A. It is in your textbook also. It is in the blackboard. Okay, I already uploaded these tables, so you can see those tables under the tab tables. Then you can see the first table A1. What is that? It is binomial probabilities. Okay, binomial probability table. So it was here, this one. This is the one, the first table, binomial probabilities. Okay, now I will tell you how to use that table to find binomial probability values. Okay, here the thing is, the table A1 list binomial probabilities. Select values of n and p. Okay, that means if you have some if we have some selected n and p values, we can find the specific probability value. That means you don't want to use the binomial probability formula. Just use the table and pick the corresponding probability value. That is your final answer. But you can't use these tables for all problems. Why? Because according to the table, you can see we have very specific p-value. But remember, in previous example, our p was 0.45. Remember, it's 45. But here, can you see 0.45? No, we have only 0.4 and 0.5. So if you have example like previous one, then you cannot use this table. So we cannot use table every time. Okay, but in the exam, sometimes I will tell you Specifically, I will tell you use binomial table. Then definitely you have to use this table. According to the table, I will give you P and Q, P and N. Okay, because if I have to, if I tell you to use binomial probability tables, then I will give you P values from this range. Okay, definitely. So if I ask to use table, this table, you have to use this table, otherwise you can use a normal formula. Okay. Okay, now I will tell you how to use that table. This is the way of using that table, but I will not read this one. I will show you using some examples. If you want, you can read this. Okay, this is the procedure, but I will show how to use the table using some examples. What is our next slide? Yes, we have 6 examples. I will show you how to find these probability values using table A1. Okay, find the following probabilities using the binomial table. So you have to use table. Here, the first question, we have N and we have P. If we know N and P, we can find this probability. You know, normally we using binomial probability formula, we can find this, but now we are going to use table. So you don't need to use that formula. Just use the table and write the value. So that is the final answer. Okay, now I will show you how to do this. Okay. Okay, the slide number 35. The first one means A. Part A is, I have to write everything because you can't see the slide. N is 2, P is 0.3. Now we want to find this. Okay, x is equals to 1. Okay, now we have N, P, and we know the x value. So how can we use the table? In here, now I will show you the table. Okay. Okay, this is the table. Here our n is, you have to pick it from here, n is 2, then p is 0.3, p is, this is our p, from here it's 0.3, n is 2, p is 0.3, then x is 1. So this is our x row, x column, x is 1. So under n is 2, that means this part, x is 1. Then x is 1, then go along and, sorry, this is p. P is 0.3, okay? So, wait, I will, okay. Here, n is 2, then x is 1, then go along this line, then p is 0.3. So, this is the value, okay? This is the value we want to get. So, this is our answer. So, write it down, 0.420, okay? Point. So, the answer is 0.420. Okay, now second one is n is equals to 4, p is equals to 0.6. Then we want to find probability of x is equals to 3. Okay, n is 4, p is 0.6, x is 3. Now we have to use the table again. Okay, now What is our n? N is 4, x is 3. X is 3. Then P is 0.6. So go through this line 0.6. So this is 0.6. P is 0.6 here, 0.6. Here n is 4 and x is 3. So this is the value. What is the answer? 0.346. 0.346. Okay, I will write it here. 0.346. Okay. Now next one. C part. N is equals to 5. P is equals to 0.1. Then what is the question? X is equals to 0. Okay. N is 5. Here it's 0.1. X is 0. Okay. Now we are going to use the table again. Here n is 5. X is 0. N is 5. X is 0. Then go here. Sorry. Here. Then P is 0.1. So this is the answer. 0.590. 590. Okay. Then part D. N is equals to 7. P is equals to 0.70. Then last one, probability of X greater than 4. You want to find this value, but here can you see we in previous cases we have equal mark. Now we have inequality, greater than symbol. So if you have any inequality, the first thing you have to recognize what are the corresponding X values. Here the total sample size is 7. Here it says X values should be greater than 4. So what are the possible X values? It should be greater than 4 means 4 is not included. Then next value 5, 6. Up to what number we have to write? Up to 7. Why? Because our sample size is 7. So we can write up to n. So we have 3 X values. Okay. Now this is the question. You can write it as this. Okay. You can separate. Then we have 3 parts. Now using table, we can find these values separately. Okay. So the meaning of this is this. Now first one is what? N is 7, P is 0.7 and X is 5. According to that we can find the value. N is N is 7, X is 5. N is 7, X is 5, P is 7, 0.7. 0.7. So this is the value, okay? 0.318. 0.318. Then next one, N is 7, P is 0.7, X is 6. Okay, here N is 7, X is 6, P is 0.7. So next value will be this 0.274. I will check the last one also. In the next one, N is 7, X should be 7, then P is 0.7. So it will be this. So these are three values you have to write. 0.318 plus 0.27, sorry, 0.247 plus 0.082. Okay, so these are the three values you want to pick from the table according to each and every x value, like x is equals to 5, 6, 7. N is same, it's 7. P is same, it's 0.7. But here x should be 5, 6 and 7. That's why we have 0.318 plus 0.247 plus 0.082. Okay, so I will write next two values. Uh, okay, those are the two values, 0.247 plus 0.082. Then what is the value answer? It's 0.647. So this is the answer for part D. Okay, now the part E, here n is 6, p is 0.40, and you want to find x is less than or equals 2. The first thing, if you see inequality, you have to recognize what are the corresponding x values. Here x should be less than or equal to, that means x should be 0, 1, 2. Okay, because here we have equal marks, so you have three parts. Now you can write this as probability of x is equals to 0, probability of x is equals to 1, and probability of x is equals to 2. Now separately find these three values using table. N is 6, P is 0.4. Likewise, we can find, I will see. Okay. The first one, N is 6. Okay, N is 6, X is 0, P is 0.4. Here, this is the value. Then next value is N is 6, P is same, X is 1. That will be this one. The next value will be N is 6, P is 0.4, and X will be 2. So it will be this. So you have to add these three values. Okay, I will take these three values one time. Okay, I will not show you at 3 times. These are the three values you have to pick and add them all. 0.047 plus 0.187 plus 0.311. Add these three values. Then you will have your final answer. Okay. Okay, I will write it here. The first value will be 0.47 plus 0.187 plus 0.311. So what is the final answer? 0.545. Okay, so this is the answer for part E. Then we have special question. What is that? Okay, I will read. A student takes an 8-question true-false exam and guesses on each question. Find the probability of passing if the lowest passing grade is 6 correct out of 8. Okay, so that is the question. First question. So we it that exam has 8 questions. So n is 8. Then true false exam. So definitely true false means this true is success, probably success, false is failure. So if each and every question has two guesses, definitely the probability of success, the probability of getting true answer is half. Okay, then give also 1 minus p, it's half. Okay, now we know npq. Actually, we don't need q. Why? Because we are doing this using table. Okay, so yeah, then we have np. Then find the probability of passing if the lowest passing grade is 6. Lowest passing grade is 6 means it can be 7 or 8. Okay, not only 6. Lowest passing grade is 6. Correct out of 8 answers. 8 questions. That means, sorry, 8 answers. Because if we have 6 correct answers, you will pass. So if you have 7, definitely you will pass. If you have 8, you also pass. So you want to find this. Okay, what is the meaning of this? What are the possible x values? 7, 6, 7, 8. Okay, because it says uh, the lowest passing grade is 6 correct answers out of 8. Okay, so this is the way of writing it. Now we have 3 parts. We can write it separately. X is equals to 6 plus x is equal to 7 plus x is equals to 8. Okay, now we have n as 8, p as 0.5, x x is 6 or 7 or 8. Okay, now we can use the table. N is 8. Here n is 8, then p is 0.5. That means this column. Okay, this column, then x is 6, 7, 8. X is, oh, so 8, n is 8, p is 0.5, and x is 6. First x is 6, so that is this. X is 7 means this. Okay, here, okay, here x is 6, 7, 8. So according to that, n is 8, then p is 0.5. These are the 3 values. So I will pick at one time. Okay, 0.109 plus 0.031 plus 0.004. So you have to add these 3 values, because in first time n is 8, x is 6, p is 0.5. Next time n is 8, x is 7, p is 0.5. Last time n is 8, x is 8, n is, sorry, p is 0.5. So the corresponding probability value is this. So you have to add these 3 probability values. Okay. Okay. So these are the corresponding probability values. So what is the final answer? 0.144. What is that? X greater than or equal to 0. So this is the answer. Then we have another question. Is this event likely to occur? Is this event likely to occur? Yes or no? Yes, it's likely to occur. Why? This probability is greater than 0.05. Remember, I told you, if you have any probability value greater than 0.05, we can say that event is usual event, likely to occur. So we can say yes, uh, it is likely to occur. Okay, so that is the answer. So this is the answer. These are the answers for slide number 35. Now we have another example. Again, you have to use the table. Okay, exercise using table A1, that is binomial probability table. Here it says suppose 30% of teenagers have a part-time job. Okay, so what is our P? According to the questions, we can see our P should be 30%. Then if 5 teenagers are selected at random, so what is our N? It is 5 because we have 5 teenagers. So N is 5, P is 30%. 30% means 0.3. Then we have 3 questions. Okay, we will get those probability values using the table. Okay, I will show you using table. Okay, this is the question, slide number 36. It says suppose 30%. So I told you if it's 30%, then how can we convert this into decimal? 0.30. Okay, so this is what? This is our P. Then we have 5 teenagers, so N is 5. So we have N and P. Then what is the first question? What is the probability that none of them will have a part-time job? None of means what? Write it as this expression. None of them means x should be 0. So you have to find this one. Okay. Now we know what is n and p. Then x is 0. Now use the table. Okay. N is n. Okay, n is 5. N is 5. X is 0. Here x is 0. Then p is 0.3. So this is the answer. 168. 168. Okay, now second one. What is the probability that at most 3? At most 3 means what? I have to write it. At most 3. You have to know these keywords. Okay, at most 3 means 3 or less. Please remember. Okay, at most 3 means 3 or less. Then you have to find what is the probability that at most 3 of them have a part-time job. So you have to find this probability. 3 or less means 3 or less. Okay, this is the question you want to find. So what are the corresponding x values? X can be 0, 1, 2, 3. Remember, I told you if it's inequality, you have to find the corresponding x values. Now you can write separately. Okay, actually in first part we got this one. X is equal to 0 means 0.168. Then you have to find rest of these values. X is equal to 1, 2 and 3. N and P is same. Okay, N is 5, P is 0.3. N is 5, P is 0.3. So now we have to write X is equals to 1, 2, 3. These 3 values. Okay, previously we wrote this one. Now we have to add 0.360 and add 0.309 and plus 0.132. Okay, these 4 values are the answers. You have to add them all, these 4 values, then that will be your answer. Zero 0.360 plus 0.309 plus 0.132. The answer is 0.969. Okay, so this is the answer for the second one. Now last question. What is the probability that at least one means one or more? Please remember, okay? So x greater than or equals to 1. You have to find that. Then in here we have 5 teenagers. So you have to write what? How many x values? X is equals to 1, 2, 3, 4, 5. You have to add 5 probability values. But I told you if you have something like that. Okay? Here it's 1, 2, 3, 4, 5. Here it's 0. Here it says these 5 values. You have to add x is equal to 1, 2, 3, 4, 5. But I told you this total is 1. Remember? Then you can do is this 1 minus only this probability value. What is that? 1 minus probability of x is equals to 0. Then if you subtract this value from 1, you will get the rest. So that will be our answer. Okay. So what is that one? Probability of x is equals to 0. Actually we got that value here. The first part, it is this 168. So I will just write it here, 168. So what is the answer? 0.0832. So the answer for the third part is 0.832. If you want, you can separately add this value, this one, this. X is equals to 1, x is equal to 2, 3, 4, 5. Or the easiest thing is 1 minus rest. It is only 0 value. Okay. So this is the final answer. Okay, now we have new part. Okay, this is the last part of this section 5.2, parameters for binomial distribution. Okay, in here I am going to show you how to find parameters in this distribution. It's very simple. Here can you see the mean of the binomial distribution is this, the formula mu. I told you if it's parameters, then we cannot write x bar or s squared. If it's about parameters, then it's about our population. So this is population parameter. Okay, this is also. So how to find population mean? Mu is n times p. So it's very simple. So if you know n and p of binomial distribution example, then you can find the mean. Also, if you want to find variance is n times p times q. Then if you want to find standard deviation, take the square root of variance. Can you see here? Sigma, just sigma is standard deviation. Take the square root of this formula, square root of npq. So very simple, simple 3 formulas. Okay, mean, variance, standard deviation. So it's very easy. Why we need this? Because the formulas for mean, variance, standard deviation presented in uh, actually section 5.1. Okay, work for only discrete probability distribution. However, these formulas require that we have all the px values. That means to find the parameters like population mean, variance, standard deviation, we need all px values. That's why it's really difficult to find all probability values for each and every x. That's why we have these formulas. Then you don't need to calculate these values separately. You don't want to add. Just use these formulas. Mu means n times p. Likewise, this is the easiest way. So we can use following formulas to find parameters binomial distribution. Okay, now how can we interpret these results? Okay, the range rule of thumb can be helpful to determine if values are unusual without needing to calculate the probabilities. Okay, you know how to interpret if you have usual or unusual value. You can use range rule of thumb. That means you can find minimum usual value using mu minus 2 sigma and maximum usual value using mu plus 2 sigma. So if you know those two boundaries, you can tell is it usual or unusual without calculating the exact probability value. So what is recall, values are considered unusual if they are more than 2 standard deviation away from the mean. Yeah, that's why I told you um, the minimum boundary and maximum boundary depends on mu and 2 times sigma. Okay, then okay, now we have an example. It's about twins. Okay, so try to do this one, then you can understand how to get usual and unusual values, how to recognize using your mean and standard deviation. Okay, here uh, 3% of all American births results in twins. That means 0.03. Okay, 3% means, then if a random sample of 8,000 births is taken, so what is our n? This value. Find the mean, variance and standard deviation of the number of births that would result in twins. This is very simple. Here you want to find mean, variance and standard deviation. To find mean, we know we need n and p. This is our n, this is our p. So we can find these three parameters. Okay, we will do this. This is slide number 39, example twins. Okay, here it says 3%. Please remember, if it's 3%, then you have to write it as this way. Okay, then the meaning of this is 0.03. 3% means not just 0.3, it's 0.03. Okay, now what is our n? 8,000. We have, what is this? P. We know P and Q. Sorry, we know P and N. Okay, now if we know P and N, we can find mean. Mean is N times P. N is 8,000. P is 0.03. So what is our mu? It's 240. Then next one is variance. It's N times P times Q. N is 8,000. P is 0.03. Then how can we find Q? Q is 1 minus P. 1 minus 0.03. So it's 0.97. Okay, now we have these three values. So what is the answer? 2, 3, 2.8. So this is the variance. Then how can we find standard deviation? Take the square root of NPQ. That is, take the square root of 3, 2. Actually, it's good to write the whole number. Okay, otherwise it will be wrong. Take the square root of this value. Then it is this 15.258. Okay. Um, okay. Then how can we find minimum usual value? Mu minus 2 sigma. That is the lower boundary. So mu is 240 minus 2 times what is our standard deviation? This one. So what is the minimum usual value? 209.484. Okay. Then how can we find the maximum usual value? It's mu plus 2 times 15.258. So what is the answer? 2 70.516. Now we have our two boundaries. Okay, now if any value in between these two values, we can say those values are usual, otherwise those values are unusual. Now what is the question? The first one, it asks, would observing 200 twins, here it's 484, here 2, actually this is about twins. Okay, so you can round. Here it's lower boundary is this. Okay, so first question, would observing 200 twins, 200 is, it is in here. Okay, so if you have any value in between these two values, those are usual, otherwise unusual. So what can we say about this value? It's unusual. Okay, so we can say the first one, is that unusual? Yes. Okay, the first part. Then the second one, would observing 150 twins, actually change it into 250. Okay, otherwise both answers will be same. So the second one, change it into 250 instead of 150. Okay, now we have here, this is the lower boundary, this is the upper boundary. Now I ask change 150 to 250. Okay, if you have any value in between these two values, those values are usual. Here, so we have 250. That means would observing 250 twins out of 8,000 births be unusual? No, it is not an unusual, because that 250 is within these two boundaries. Okay, so the second answer is no, because we pick 250. Okay, change 150 to this value. Okay, this is all about this example. So it's very easy. If you want to find usual and unusual values, then you don't need to find the exact probability. Using this range rule of thumb, you can get the idea about your ob observation. Is this a usual value or unusual value? Okay. uh, okay, this is our last slide, slide number 40. This is same another example, but with different values. Okay, it is about exam. It says a midterm exam consists of 50 multiple choice questions. Okay, so according to the question, what is our n? It's 50. Then each question has 4 choices, of which only one is correct. Okay, so what is the correct success probability? It's 1/4, because out of 4 choices we have only one correct answer. So the probability of success in each trial is 0.25. So you know P, it's 0.25, N is 50. Then the first question is find the mean, variance, standard deviation. Then we have another question. Okay, if you want to find mean, variance, standard deviation, you can use those formulas. Okay, now I will show you how to do this one. Okay, the first part, first thing we have recognized what is your n, it's 50. Then what is your p, it's 1/4, that means 0.25. Then the first part is we have to find mean. What is mean? Mu is n times p. N is 50 times 0.25. So mean is 12.5. Okay, then what is variance? It's NP, sorry, NPQ. So n is 50, p is 0.25, q is 0.75. So our variance is 9.375. Then what is the standard deviation? Take the square root of n, p, q. So that means take the square root of this value. It is 3.062. Okay. Then that is about first part. Then what is the second question? It asks, would it be unusual for a student to pass the exam by guessing? What is the meaning of guessing? Assume a passing grade is a 60%. That means 30 correct out of 50. So we want to find what? Would it be unusual for a student to pass the exam by guessing? So assume the passing grade is 30 correct out of 50. Okay, so the first thing, if you have something like this, you have to find your minimum usual value and maximum usual value. So what is the minimum usual value? 12.5 minus 2 times standard deviation is 3.062. So the minimum usual value is 6.376. Then what is the maximum usual value? It is 12.5 plus 2 times 3.062. So the answer is 18.624. So these are the two boundary values. Okay, so that means we know we have 50 questions, like 1 to 50. Then boundary values are 6.4 and 18.6. Okay, so if you have any value in between these two, we can say it is usual thing, usual to guess. But but here it says passing grade is 60%. That means it should be 30 correct out of 50. So this is 50, this is 1. So this is the usual range. But if you can guess like 15 correct answers, but it's really difficult, it is really impossible to guess 30 correct answers. Okay, if you can guess 30 correct answers, you can pass. But according to these two boundaries, um, actually it should be according to these two boundaries, if it's usual value, then definitely those values in between these two boundaries. But according to the question, how can we guess 30 correct answers? Because here it's really unusual. So we can say it is unusual for a student to pass the exam by guessing. Okay, so why? Because 30 correct answers is out of the boundaries. Okay, out of the upper boundary. So we can say, would it be unusual? Yes. Why? Because 30 is an unusual value. Okay, so this is an unusual thing because 30 is out of boundaries. Okay, so 30 is an unusual value. Okay, so if you know mean and standard deviation, you can tell about usual and unusual values, okay, in your data set. Okay, this is all about chapter 5, and this is our last slide. If you have any question about this chapter 5, please let me know, then we can discuss about this content. Okay, thank you very much.